Thank you very much. It's a pleasure to be here, and I thought because you're a geeky audience, because it's a tech show, I'd focus on one particular area of research that I'm interested in, and links, remarkably to my mind, cosmology with information theory and quantum mechanics and quantum computing. So it's the exploration of space and time and the exploration of black holes. But I thought I'd just begin just with a brief overview of the challenge of cosmology, because we're speaking about cosmology, which is the study of the large-scale structure of the universe. It is the science within which we ask questions about the origin of the universe, and very deep questions actually about why the universe is the way that it is. And to set the scale, this is an image, it's one of my favourite images of our galaxy, the Milky Way, which was put together by the European Southern Observatory. And it's the Milky Way, as you never see it from a single point on the Earth's surface, because it's photographs from both northern and southern hemisphere stitched together. So it's the entire arc of our galaxy across the sky. The southern hemisphere sky is in the centre of the image, and the northern hemisphere, our sky, is on the left and right hand side. Now, I show you this just to get a sense of the scale of the challenge, the intellectual challenge that we're talking about. I mean, this galaxy, our galaxy, has around 400 billion stars in it, 400,000 million suns. We now know that most of them have planetary systems. Pretty much all of them have solar systems. We've detected now over 5,000 planets directly around stars in this galaxy, which allows us to do some statistics and answer questions such as, well, how many potentially Earth-like worlds are there in this galaxy? So that's rocky planets, the right distance from the star, potentially, to support liquid water on the surface. You can see its structure. You're taking pictures of it. You can download it, actually. It's on the Hubble Space Telescope website. One of the remarkable things, you can see this actually from here with a small telescope, if you know where to look. The yellow colliding with the whirlpool. So what you're looking at here is an interaction, a collision between galaxies. So that's one of our nearest neighbours. This is what they look like. Stepping out again, and this is our first data set of the morning. This is now a visualisation of data. It's always very useful to be able to visualise data sets, as you know. This data set is called the Sloan Digital Sky Survey, which is a project to map the position and distance to galaxies in the sky. So each point of light in this fly-through is the measured position of a galaxy. So this is a real 3D map of the universe. I should say we're at an IT conference. This was playing beautifully smoothly in the rehearsal, and now the IT has failed and it's jerking. Anyway, you get the sense. I might unplug the HDMI. Are there any techs in the audience? You can unplug the HDMI lead. Anyway, this is a fly-through of the local universe. And you see that on this scale. So I should say each point of light in this fly-through is the measured position of a galaxy. And where we had the photograph of the galaxy, then we used it in this simulation. So this is as close as you can get to seeing the large-scale structure of the local universe. It's fairly empty, actually, from the surface of the Earth, not particularly remarkable, so an average piece of sky. But in this image, you can see just a few things that exhibit a star-like distortion. So those are stars in the foreground in the Milky Way galaxy, but there's only, I counted about 6 or 7 of them. You can see a big one right at the top. So about 6 or 7 stars in this image. Everything else is a galaxy. It's a dazzling image. There are thousands and thousands and thousands of galaxies in this image. And there's actually one. I've got a laser pointer here. It's this one, so I'm going to blow it up. So that galaxy there is actually the most distant confirmed galaxy that we have. It's called GNZ11. And this is a galaxy, so you're seeing that as it was 430 million years after the Big Bang. So because the light travel time is well over 13 billion years to that galaxy. So you're looking there, that little red blob is one of the first galaxies to form in the universe. And in this image, which as I said came down 2 days ago, the claim is, I don't know, I can't see it, but the claim is they can detect the signature of a supermassive black hole in the centre of that galaxy, that little red blob.